So I want to thank first the Texas Tech's Climate Science Center for inviting me to give the presentation. And I also want to thank everybody who's shown up. I appreciate you being here. What I'm going to be doing today is taking you through part of some of my research. This is centered around climate science and how it's impacting water resources in the desert and what that means for wildlife. And this is a compilation of work from my lab, as well as some collaborations with other scientists. But what I'm going to be talking about today is climate change in the Sonoran Desert and how wildlife managers are dealing with these water resources. Then I'm going to talk more about water quality and what that means in the context of climate change. And then what that means for a variety of wildlife. So things that use these waters for a place to live, as well as use water for drinking. And then we're going to bring everything back together and talk about some of the challenges we're still facing with this management. So we're focusing in on the Sonoran Desert and work that I've done down there. I've been working for over a decade now on some of this work. This is a landscape dominated by rocks and cactus. It's hot, it's dry. As you can see here, I'm very overheated sitting in the shade. And most people that are working outside there are smart enough to work in like cooler seasons, like spring, fall, winter, but not us. We're out there in the summer because what I want to do is focus when water is most important. So when it's hottest, also when it's driest, which is early on in the summer before the monsoons hit. My goal is to help land managers refine their management of waters because water is becoming less available. And it is so absolutely critical for wildlife and continued wildlife in this region. Okay, also up here, what I'm showing is a tinaja, which is one of the natural waters out there. It's just basically an erosional depression in the bedrock that holds rain. And these are really important for wildlife out there. Okay, now I want you to imagine that it's over 115 degrees, which is a lot hotter than most of us are comfortable tolerating. There's really no shade trees. There's not a whole lot of permanent water sources either. Where I've had work going, there aren't any rivers. There are very, very few springs. And we need water. It's critical for hydration, for our basic metabolism. It's also really important for cooling us down in this really hot system. And so it's important for even those big sexy species like Sonoran pronghorn and desert bighorn that may not need as much water at other times of the year. It's also important for things like amphibians. You can see one here mummified on a rock. If they don't have water for hydration, they don't do so hot. They've got this naked permeable skin, but also they use water as a place to lay their eggs and for their eggs to hatch and tadpoles to develop. So it's important habitat for them. Now, we're talking about an extreme environment already. So what effect is climate change actually having on this really, really hot and really, really dry system? Now, before I go further into that, just a really brief talk about what climate change is. And what's causing it. And so when we're talking climate change, we're just talking about how global temperatures are changing. That's kind of the basis. And since basically the Industrial Revolution, they've been increasing. And that increase has caused or has added energy into weather, which is causing all sorts of fun extremes and so forth, like huge rains we've been getting and snows on the West Coast and other places. But I also want to point out there's a difference between climate and weather, and it often gets conflated in the media. So I just wanted to touch on this really quick. Climate, when we're talking about climate, we're talking about a long-term average. It's normally like a 30-year moving window, so it's very predictable. We can see the change. And that's represented by, let's see, the red line, the red trend line, versus weather, which it's looking out your window. Like we have a snow day in Lubbock right now. But even seasonal or yearly variation, that's weather. And that's extremely variable, relatively unpredictable. So climate, very predictable, weather not. Okay. Now, climate change itself, what's going on here? We're going to talk about greenhouse effect really quickly, because it's important to know why the Earth is warm and why it's warming up. So we get heat from solar radiation. Heats the Earth's surface, some of that bounces back out, and then bounces off and is kept in by this nice blanket that we have of our atmosphere. We've got greenhouse gases that keep the Earth's surface a lot warmer than it would be otherwise. Now, we've been pumping extra greenhouse gases into the atmosphere since the Industrial Revolution, and that has basically increased the size of that blanket. And no one wants a giant blanket when it's 115 degrees out. Too much of a good thing is not good. And that's basically what's going on. That's why we're getting this change in climate. And that's how we're getting lots of energy added into, like the storms we're seeing. We're getting longer droughts. We're getting more or larger hurricanes, things like that. It's getting hotter. And what you see here on, let me get my laser pointer. This is my study area. And this area is already seeing 2.5, 3 degrees in warming. And so that might not sound like a lot, but it has a huge impact in weather patterns. Also has a huge impact on the amount of water around. Because even if you had precipitation staying the same, you got the same amount of rain. If you have temperatures going up, especially in an arid region like this, you've got your evaporation going way up. And so the amount of water that you actually have available is going down. And what we've got here is a graph showing drought in the Southwest. And so we've got from 2000 up to 2020, and then the percent of land area that is encompassed in that drought. And you can see a lot of the Southwestern US has been in significant drought over the past 20 years. So how have wildlife managers been dealing with this? With less waters in these isolated kind of stashes that we manage for wildlife. Now let me introduce those. Wildlife historically in this area used water that collected in these tanahas. Like I showed you earlier, the solid bedrock bottom, so they aren't connected to groundwater. It's just collecting precipitation. Some are connected to springs, but not many in the area that I've been working. Managers have altered some of these to hold water longer. You can see on the left, but they've also built catchments, which you might also call them guzzlers. These are just systems that catch and hold rain in reservoirs, and then they let them out these troughs. And the troughs are set up to reduce evaporation. So the whole system, you want to keep water out there as long as possible because you're in the desert. It's a water limited environment. Any way you can keep water out there and provide it, you're doing something good. At least that's what we think. And so managers have had this water supplementation program going on since I think it was the 1950s. And they have done a good job of providing water. I mean, we're talking hundreds of thousands of gallons a year just in the state of Arizona alone. And so they're providing water when there's not a lot of water available, when it's very, very hot, when it's most critical. And because water is so critical, it's important that we do this management in a smart way, in a way that's efficient and in a way that supports wildlife populations. And so that's where I come in. Now, a lot of different species use these waters. There are species like Sonoran pronghorn, which is an endangered species, desert bighorn, whitetail and mule deer. You've even got bobcats and javelinas and songbirds, and even species we don't think about as much, like the Gila monster. And then my favorite ones are the toads. You see here the Sonoran desert toad. We've also got mountain lion, but I really put it up there because you can see the toad behind it. And so they're all using these waters. And so managers put in this system and put in these waters because they were targeting certain species they were interested in. Could be an endangered species like the Sonoran pronghorn, game species like mule deer, even quail. But those aren't the only species using the water. So the way this project actually started was, how do these water sites do at supporting both the game species, but also non-target species, things like toads, because toads are awesome. All right. Now, water quantity is only one part of the equation when you're managing this resource. But let's go through the whole process. We know climate change is increasing temperatures, and warmer temperatures mean that the water available is going down. It's evaporating faster. It's not there for wildlife to use. And that means the amount of time water remains in one of those water sites goes down. That's called a hydro period. So you've got a shortening hydro period, shortening time water is available. Now, it also affects water quality because, okay, simple basic physics is water warms, it holds less dissolved oxygen. It's just the water molecules move more and it gases out faster. So there's less dissolved oxygen. At the same time, you've got bacteria and algae and invertebrates and amphibians all in the system, and they all have metabolisms that respond to ambient temperatures, meaning that they're ectotherms. So as it warms up, their biological activity goes up. That means for those that actually use oxygen, they need more oxygen. They also feed more. They also produce more waste. And so you've got all this going on in these small systems that's evaporating faster. And that means you have that concentration of waste. And that starts going through decomposition, and you end up with these inorganic nitrogen ions. So nitrogenous waste that turns into ammonia, nitrate, and nitrite. Now, we went out and we looked at these systems to see, okay, are we seeing a problem with waste, a problem with water quality? And we did a whole bunch of different things. We looked at amphibian use by putting up these audio data loggers, so we didn't have to be on the site, because can you imagine having this huge area to survey and the only time the toads come out is at night when it rains? So you got to figure out where the rain is, when the toads come out, and it's hard. So we've got these data loggers out to help us determine when they're there. We've also looked at the invertebrates. We've sampled water quality. We looked at other aspects of site quality. We've also done things that I'm not talking about in this talk today, looking at landscape context and disease. And those are for a different talk another time. But we spent a good amount of time assessing site quality. Okay. And we found nitrogen ions. We found lots of ammonia. And so this is from back in 2012. And there's a reason I'm showing you this, and I'll go into why just a second. But if you looked at those constructed catchments versus Tanahas, there was a really big difference. This was after monsoon rain started because we wanted to see how this was working for toads and dragonflies at the time. Huge difference in the amount of ammonia, which was really surprising. And this caught my attention because I actually had done work on nitrogen before during my PhD, and this was not expected. Background levels of ammonia in water systems are generally less than 1 milligram per liter. Now, this is, let's see. So this is Tanaha versus catchment. So on the X, you had the two different water systems. My hands, you can't see my hands, use a pointer, and then ammonia. Now, it's not that catchments are bad and Tanahas are good. That's not what's going on here. This is when we actually were able to get, look at water quality before the rains hit, right after the rains hit, and then during the winter. And you can see in the Tanahas, and so this is just Tanahas, in the summer pre-rain, summer rains, and then winter, it gets really nasty in those. And any of you that are from that region know it's really nasty. But what happens is they eventually, or what happens is rains come. I've got pictures to show in just a moment. But the difference after the rains come, the difference in that nitrogen that build up, the ammonia that build up, is because what happens in the catchments, the reason they don't clean out is you've got this organic matter, like dead bees. We're working in killer bees out there. Dead bees accumulating dead things, algae and so forth. And that settles in the water. It decomposes, releases these nitrogenous wastes. You've got a small surface areas, and you've got bees and algae keeping the ammonia from going off. In addition to the catchments not cleaning themselves. And so that's why the catchments had such a high concentration of ammonia during the monsoon season. Now, let me show you what I mean by cleaning out. So this is, this right here it's actually an empty Tanaha. That's black bottom tank. And when a good monsoon comes through, you get rains. And this is what happens with it filling up over about a 30-minute period. You have water coming through violently enough that it like pushes all that organic matter out and washes it down and basically resets water quality. And then toads have a happy place to breathe. But this is not what happens in the catchments because we didn't design them that way. But this also begs the question, well, if Tanahas are getting cleaned out, catchments don't self-clean, why don't we just clean them? And so Arizona Game and Fish and others have been doing that. And this is actually a picture of Stephanie Dories. She is lead on the Sonoran pronghorn recovery program, mucking out one of the waters. This is hard. These sites are, a lot of them are remote, and it's really, really hard work. It takes a lot of time, but it does have an impact, which I'll show you. So we're going back to that original graph I showed you where it was catchments versus Tanahas. This is 2012, after the monsoons start, in the ammonia concentration. So ammonia concentration. Now, if we just look at catchments now after their cleaning, they actually are doing a lot better than the original graph. So we've got here, this is where the average was without cleaning. And we see that in all cases, all seasons, that level of ammonia has gone down. which is really good. It is really good. And actually, the reason it's lowest here during the summer pre-rain is that's normally when managers can get to the waters because there's less water in there, so it's easier to clean out. And so they've been having a measurable effect, which is awesome. So this is showing catchments over here, Tanahas on the right. And you can see the catchments are fairly consistent through the year in their level of ammonia versus the Tanahas. We have pre-rains, we have a whole bunch in there, and it seriously goes down with the rain and after. Now, this is important for a lot of different types of wildlife, and the timing actually is important too. So let's talk about ammonia and wildlife, actually nitrogen and wildlife. First, we're going to talk about amphibians because they use these as places to live. And aquatic organisms actually can respond strongly to ammonia. So what we have here, this is kind of a normal precipitation year, not drought. So ammonia concentrations, site type, catchment versus Tanaha. And what I'm showing here with the red line is the US EPA has freshwater quality criteria for ammonia for these small eutrophic systems that are pretty nasty anyway. Not really what we'd consider drinkable, but what is levels that we need to be concerned about. And for them, that's 1.9 milligrams per liter, which is way the heck down here. So we're seeing concentrations much higher than that. Now, the level of that ammonia depends significantly on whether it's a normal rain year or a drought rain year. And so we have normal rain years over here. Tanahas are doing really well. Catchments are doing okay. But during droughts, neither one is doing a great job because you don't have enough water entering the system to dilute anything. And this is important because it gives us an indication of what the wildlife is going to be facing in the future, what type of conditions that they're going to have to be dealing with. And that is they're going to be dealing with a lot poorer water quality. But, you know, maybe the toads can avoid the ammoniated sites. Maybe they don't use them. That'd be grand if that's what happened, but it's not. So what I'm showing here is, this is a number of years went into these averages. And on the x-axis here, I have the size of the amphibian chorus. This is the information we got from those audio data loggers that record choruses, and then ammonia concentration. And whether you're there in person or you're recording it, there's a standard index that we use for quantifying chorus level, because as much as we want to be able to count the number of toads singing, it doesn't work. So it's either there aren't any, there's just a couple of them, there's a few, but there's not a lot of overlap, or you've got a full chorus. And so that's what's showing here. And so what we see is there's no response to ammonia level. This ammonia concentration is when they're out there breeding. So no, they're not avoiding. And we know that ammonia is harmful to amphibians. It slows growth and development of tadpoles. It can lead to deformities. It can mess with the immune system and cause them to be more susceptible to disease. It can lead to death. And it can do this at levels that are really low and really important when we're talking about things getting drier. So our drought years are giving us an idea that we might need to be doing something about water quality because these conditions are not going to support the amphibian community very well. definitely not for reproduction. Okay, now let's talk about mammals. Now, we know lots of desert mammals, they do really well without drinking. A lot of them can get water from food they eat, which is true. But what we've seen is that when things get really dry, they'll use water. And so what you see here, these are graphs of the number of visits by different species to wildlife waters by day. And so this is from April through November. And this is desert bighorn. We've got mule deer, we've got whitetail, and then just Sonoran pronghorn. That information is from the literature, basically saying same thing. When water resources are low, there's a lot more visits. So yes, they are using these wildlife waters. They are important. They're using them during the hottest period of time. This also happens to be when at least some of the species are either pregnant or lactating. And females that are pregnant or lactating need more water, just simply need more water. They're supporting more than their own body. They're producing milk. It's absolutely critical. And so what I'm showing here with the blue arrow is the same date that this picture was taken at Thanksgiving Day take with desert bighorn ewe and her lamb coming down for water. So it is an important resource for mammals as well. But again, maybe they're smarter than toads. Maybe they can avoid sites with poor water quality. Well, we've gone through and looked at same day concentrations. We've matched up concentrations with visitation by a whole bunch of different wildlife, and there is no avoidance that we can tell. They're using these sites with whether it's high ammonia, nitrate, nitrite, and that's not good. Okay, next question is ammonia, nitrate, nitrite. Are they harmful to mammals? They are. Depending on the type of nitrogen ion that the animal's taking in with their drinking water, it can mess with how the organism is able to use the oxygen. So oxygen transfer doesn't work right. It can cause dehydration, neurological dysfunction, failed pregnancies. It can cause juvenile mortality, adult mortality. It depends on the concentration and the type of nitrogen they're getting. But with the numbers that we've measured, we went through and calculated how much mammals would be taking in based on average body weight and average water intake published in the literature. And these are for animals from this region. And both nitrate and nitrite are high enough at times that it can cause some of these negative impacts. And so if we think back to the slides about ammonia and how during drought years you get that accumulation and it doesn't really go away during the monsoon season, we really need to worry about the quality of a resource that we're providing for these animals, especially when water quality is going to get worse. So let's sum this up. We know that climate change is happening. I mean, there's not a doubt. It's reducing the amount of water on the landscape out there. It's also reducing the quality of that water. Managers are doing a really good job with improving availability, with doing site cleaning to try and get water quality improved. So they're being very proactive about it. But, based on what we're seeing with drought years, it's not enough. And so what we're doing, what my lab is doing and what we're doing with others is we're coming up with ways to try and improve water quality more and trying to make these resources enough quality that it's going to support these wildlife, whether you're talking toads or whether you're talking bighorn, so that they're better able to handle the stresses that are occurring with increased temperatures and so forth. Okay. And with that, I'd like to thank both Texas Tech and the Department of Defense for funding this. They've been awesome. I also have up here a list of collaborators, graduate student techs, and volunteers. And this is only a partial list because there are collaborators on the landscape part and the disease part that I didn't include because we didn't talk about them in this presentation. Arizona Game and Fish and the people who've been working on the waters out there, Grant Harris, who we collaborated with on the image data, and then the Ajo community. Ajo, Arizona is awesome. We have had several years, people just offer us places to stay, and just they're great and really enjoy working with them. So with that, I would be happy to take any questions.